I'm Eric Cortez. I'm a professor at Temple University, a deep sea biologist. At, as you now know, I've been friends with Rebecca for a number of years. We've been, I would say, conspiring on a number of projects. So I study deep sea corals. Here's my daughter's artist renditioning. Let me get rid of this. Let me just get rid of the background. Sorry. Okay. There we go. So corals and the ones that I study can live for hundreds, in some cases thousands of years. And so they are recording a history. And I know you guys have talked about things like this, but you can just think, you've talked about sediment layers and geological layers, and what's going on down here is also happening up here. And one of my very first projects, we cut some of these guys in half and made a whole bunch of sections and discovered that they have tree rings, and that these tree rings essentially are annual in some cases. But they are a great archive of things like temperature, where you can go back in time and start with, very cooler colors and watch it get warmer and warmer over time. If you were to visualize that, so you can also record things like where their carbon is coming from. And with Mandy, we study corals that grow very near hydrocarbon seeps and methane. And so they're incorporating fossil carbon as well as photosynthetic carbon. And so they go kind of from green and the ocean surface to black from the oil and methane that they're absorbing. And that can change over time as well. And if you were to look at my question around that is how much of, it's a very old theory called the inheritance of acquired characteristics, which is very popular pre-Darwin and was basically forgotten during Darwin. And then after that is now we're discovering that that can happen. So these corals, if you were to look at the whole tree itself, they are colonial, which means that they are clones of one another. So the organism that settled 2,000 years ago down here and experiencing one temperature, that organism, its clones are still present way up here in the branches of this tree, experiencing very different conditions, different carbon sources. The carbon that they release is in very small molecules that can persist for thousands of years in the deep ocean. That we're now starting to discover.
Okay.
And so how much of that history can they then pass on to their offspring? How does their microbiome change over the course of thousands of years of interacting with one, basically the same organism? How does that provide this continuity and memory?